All right, so in this video, we're gonna go over Venn diagrams. Yay. Now, you've probably seen this before, probably in middle school or sometime like that. But we're really gonna get into how we can use them to solve these probability problems that you're gonna encounter, and how we can, relate them to the two-way table, how we can match up the probabilities. All right, so Venn diagrams, as you probably, have seen, are essentially, these diagrams that really involve circles, and each circle represents some event. Like the circle here is going to represent event A, and the circle is going to be within the sample space. So then the universe is everything. So usually we'll have like a capital S again, remember, to denote sample space. So this rectangle represents the possibility of everything occurring. Like this rectangle is the universe, everything. So this first Venn diagram just shows that in this circle, this is where event A occurs, and outside the circle, but inside the sample space is where A doesn't occur, or A complements. So either A occurs or A doesn't occur. So A complement. That's it for that one, that very basic one. And the next one, again, we have our sample space represented by the rectangle. So the universe you can think of everything going on. And either we have event A or event B. So you can see events A and B, they don't intersect. So that means you can't have them both occur together, because they don't ever, they don't touch at all. They don't, cross over. So you can't, these will be, what we say are disjoint or mutually exclusive. Out here, we have, neither event A or B. So you could say you could say, the complement of A and the complement of B together. So that's our second basic example, mutually exclusive or disjoint events. Now we have our next two, where you have events A and B, all within the sample space, so all within the universe. And here we're focusing on their intersection. See, they intersect. So this shaded region represents A and B both occurring. So we call this the intersection. And in probability, we tend to use this upside down U looking symbol to represent that intersection. So A intersect B. So this is something you're probably going to see from here on out, instead of having to write the words out. So A intersect B, A and B is events A and B. All right, and the last one we have, again, the sample space, and we have everything in A and everything in B and everything in A and B where they intersect. So we call this event A or B, because either this satisfies what we want, this satisfies it, this satisfies it. So we call this a union, because these are, it's united, it's all together. We're talking, any of those will count, will satisfy it. So we use this U symbol, but instead of being upside down, we have, the normal way. We say A union B to represent event A or B. Now this is something that's good for you to understand this next rule, which we call it general addition rule. And it says that if A and B are two events, then the probability of A or B is equal to the probability of A plus the probability of B plus the probability of A and B. Now, right here below that, I just rewrote it by using the symbols that I showed here, showing, the intersection and then, the union. Remember, so A or B, probability of A union B, so probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, or the probability of A intersect B. Okay, so how does this work? Well, let's look at this. So if we want to figure out what the probability of A or B is, we're essentially looking at this whole thing, right? And this is what we're trying to find. We're trying to find the total probability that corresponds with this entire shaded region. So the shaded region in here and here and here. You think about the three different spots you guys think of. Now, I kind of messed up this. Now, here's the thing. if you want to find the probability of A or B, if we simply just added A and B together, what happens is you get this overlap here. Because when you have A, you get it once, right? Let's say yeah, that's your A. But then when you add B to it, you're also adding that part again. So you're double counting it. It's basically creating like maybe on the side here, maybe you have A, right? That's your A. And then you add it to B. What happens is you get this double counted. So you get this and whatever you want to call this. You get like this total, this and that. So this is the A intersect B. You get this region added extra. So to compensate for it to make sense, we have to subtract this intersection so that it doesn't double count it. Because then just think of it as area. We're gonna add think of it just adding that's probably the better way to say it. You're gonna add the area of A, and if you want to find the total area of A and B, or the total area of A and B is here, here, and here, you would add A to B, but then take away this one time because you don't want to double count it. That's all that's saying. Okay, so let's go through an example, because again, this is always the best way to understand this stuff. All right, so here we got phone usage. So according to the National Center for Health Statistics, in December 2012, 60% of US households had a traditional landline telephone. 89% of households had cell phones, and 51% had both. Suppose we randomly selected a household in December 2012. Part A, and let's make a 2A table that displays the sample space. All right, so we did this in an example earlier, but let's kind of refresh what we're doing here. So remember, we want rows and columns. I want to keep it as simple as possible, as few rows and as few columns as possible, making our lives easy as can be. Remember, I like to always work out from the outside totals. Total. Okay, so let's break down what we got going on. So we have statistics or percentages corresponding with percentages of landline telephones and cell phones. So we're really looking at two things. We're really looking at the statistics of landline telephone ownership and the statistics of cell phone ownership. So across the top, let's have the landlines, and then across the sides, the columns will have cell phones. Landline. Next, we need to twist this cell phone. Okay, so now again, we want to always keep this as simple as possible. So we just have one column represent that you have a landline telephone. So we'll just have L. And the other column is that you don't have a landline. So L complement. So this column represents a landline. This column represents that you don't have a landline. And we use the same idea for the cell phones. You have either you have a cell phone, we'll have a C, or you don't have a cell phone. So C complement. And that's it. That's how we want it. That way we can minimize our rows and columns, and we don't overcomplicate it. Now we just match up the corresponding percentages in the correct locations. And again, I advise working from the totals to the inside, because the totals, and if we're talking about percentages, we know it has to add up to 100%. I'm going to write it as a decimal. So it has to add up to 1.0, right? Otherwise, it wouldn't make sense. It has to add up to 1. Okay, now it says that 60% of the US households has traditional landline telephone. So this means the total of landline telephone ownership is 60% or 0.6. So I look at this first column because this gives me information about the landline ownership, and the total here, 0.6. That tells me 60% of the the people own landline telephones. And then from here, see if I have 0.6 here, and I know it has that as a point, or it has that as the 1. And I know here is 0.4. So I already have that one filled out without even having to read that. Now, here it says 89% of households had cell phones. So we look for the total of cell phones. So this is their cell phone row. And in here, so this, I put 0.89, 89%. Then that means that 0.11 or 11% would go here, because 0.89 plus 0.11 would add up to 1. So I got my totals taken care of. Now let's see what else I'm given to help me figure this out. Here it says 51% had both. So we look for the box that corresponds to having both a landline and a cell phone and put 0.51 in there. So the intersection of landline and cell phone would be right here. This box represents that they have a landline and a cell phone. So that would be 0.51. Now from here, I just fill in the rest by figuring out what numbers you got to add to get that total. The 0.51 plus 0.09 would be right there. That adds up to 60. 0.51 plus 0.38 adds up to 0.89. 0.09 plus 0.02 adds up to 0.11. And there you go. There's the table. Simple as that. Now with your table, this makes the rest of the problems easier as long as it's done correctly, which it is, hopefully. Part B, find the probability that a household has at least one of the two types of phones. Okay, so at least one of the two types of phones. So the probability that they either have a landline or a cell phone, the probability of L or C. And so remember, it says at least one. So that would include this. I would include this and this, because these two count as cell phones and these two count as landlines. So I just have to add up these three values, and then I'm going to get my answer. So 0.51 plus 0.38 plus 0.09. And I would get 0.98. All right. Part C, find the probability that the household has neither type of phone. Well, that means they don't have a landline and they don't have a cell phone. So I could basically say the probability of not having a landline, which is L complement, and not having a cell phone, so C complement. The probability of L complement and C complement. So where do both L complement and C complement intersect? So here we have L complement. Here we got C complement. So it's just this 0.02. And so that's just simply 0.02 or 2%. And you could just probably, you probably could have were able to reason out logically from here, because if you don't have either landline or a cell phone, it's basically the complement of having a landline or cell phone. Because 0.98 plus 0.02 is 1. Right, part D, find the probability that the household has a cell phone only a cell phone. The probability of C. Well, now we just look at where they have a cell phone and not a landline. So let me actually rewrite this, because that's actually would be a little misleading. A cell phone only. So that means they have a cell phone and they don't have a landline. So we could say an L complement. Probability of C and NL complement. So the probability of having a cell phone and not having a landline. So cell phone, we're talking about these values, but it has also be L complement. So we're talking about just this value. That would just be 0.38 because that is a cell phone and not a landline. All right, moving right along. Now the last part, the Venn diagram. All right. Okay, construct a Venn diagram represent the outcomes of this chance process. Okay, so start with your sample space, rectangle. I don't know what's going on there. So it's samples. Okay. Anyways, all right. So since my two events are landline and cell phone, and since we know we can have both a landline and cell phone, I'm going to start off by drawing two circles that intersect because we know you can have both a landline and a cell phone. So looking at our examples here, it could be one of these. We don't know. I mean, we'll basically want two circles that intersect. This is the basic way you draw a Venn diagram. So I'm probably going to draw these circles maybe a little bigger so I can more ovally, because circles are kind of hard to write the numbers in. It's all right, don't worry about it. Now, one of these circles is going to represent a cell phone. So this is the cell phone circle, I'll call it, just because. And one of these will be represent the landline. Now, just so you know, there's more than one way to go about this. You don't have to do cell phone and landline. You could technically do actually like L complement and then let me think. You do L complement and C complement. Well, do it this way because it will make your life a lot easier. But there is more than one way to represent the Venn diagram. Now the way I would want to advise you to interpret this is to view this as two ovals and these four values and the two ovals intersecting, because think of it as so you have 1, 2, 3, 4 things, 1, 2, 3, 4 numbers. See 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. So you want to basically figure out which of these go where. And the way we have this set up is, see, we have L and C intersecting. So we have, essentially this 0.51, because in this part right here, let me use a pen. That it represents C and L. So C intersect L. So what you would write in there is the probability of getting both having a cell phone and a landline, and that would be that 0.51. That'll be that. And then you write in here what's in the cell phone, what counts as a cell phone, but is also, not a landline. It's not also now a landline. And in here, the landline, but not the cell phone. So the landline we know adds up to 0.6. We know there has to then be 0.09 here, which is that, this part right here. And then over here, we know that the total cell phones adds to 0.89. That's our 0.38, because 0.51 plus 0.38 would be there. And then don't forget out here. Out here is not a landline and not a cell phone. C complement and L complement, and that's our 0.02.